Hi everybody. We're going to have a look at introducing the structured query language, which is SQL. And we're going to use this to be able to create our database tables, to be able to insert some information to the tables, update the information in the tables, and to be able to delete a row from our database table. Okay, so I'm going to try and break the videos up into kind of smaller parts so they might be easier to watch rather than one large video. Okay, so for the first one, we're going to look at creating a database table. Now we've seen this in kind of week one, and we demoed it in some of the videos, that we can use like a graphical user interface to create our database table, which is very handy, it's very powerful, and it's something that we need to be able to do. So it makes life a little bit easy if we wanted to follow that process in creating a table. But where the real power comes is actually understanding exactly what's happening, I suppose, under the hood a little bit, where we're able to write our own SQL syntax to be able to create our own database tables. Okay, so that's what we're going to look at in the first video. So first thing we're going to look at is the syntax for creating a table. Okay, so what we have here is the keywords that we have in our structured query language to create a table. We have reserved keywords called create table. So we will use this syntax for any table that we want to create. Okay, so we're going to build up a block which will be create table. We're going to give the table a table name, and we're going to define the different attributes that are associated with this database table, and we're going to describe exactly what type of information is going to be stored in each attribute or in each column. Okay, so this could be the equivalent of first name is going to store characters or strings, or someone's age is going to be a numeric value, or someone's date of birth is going to be stored as a date, and so on and so forth. Okay, so the syntax is quite important. Okay, so we start off with create table space, then we specify our table name, we open our roundy bracket, we specify the first column or our first attribute and its data type, we put a comma in to go to the next one, then we define column 2, specify its data type, comma, define our last entry for our attribute or column n, its data type. Obviously you can see here there's no comma after the last one. We close our roundy bracket, and I suppose for good housekeeping we'll close the statement with a semicolon. Okay, so that's the syntax that we're going to follow, and the best way to see this is to drive it through with an example. Okay, so we have our create table. So create table is a SQL keyword that's used to create our database table. So keywords are usually written in uppercase, so we'll use this the whole way through. Okay, so anytime that we may be looking at or examining some SQL code, anything that we see in uppercase, it's probably going to be one of these kind of keywords that are specifically used to do something in or against the database structure we're working on. Okay, so each column will store information of a particular type. Okay, whether it's strings or dates or timestamps, whatever it's going to be. Okay, so it's just different data types. There are a number of different types that can be used, and we'll see we've listed off maybe 6 or 8 of the common types that we'll use 90% of the time. There are a number or a large list of data types that can be used, and what we need to do is that we just need to know that the list exists, and sometimes if the kind of standard default list doesn't kind of meet the requirements of what we're after, then we can go looking at different types and use them as well. Okay, so I've added a couple of links up on web courses that give a very exhaustive or comprehensive list of the different types that can be used. Okay, so the syntax of the date types can or the data types can change slightly when moving between different databases or different vendors, okay? So we just need to be a little bit aware of that too. So we won't complicate it for us. First little example. So we have create table, and we're going to have a look at some of the data types. So the first one that we can look at is car. So we're saying that something is going to be car size. So it could be car 10, car 100, car 255. So it's a fixed length. Whatever we define, that space is going to be allocated to that particular variable, okay? So then we can use something that can be a varchar, which is of variable length, i.e. it's only going to store the space that it requires to store something, but we can define the overall maximum size of it. So varchar 40, varchar 50, varchar 255, whatever, okay? If we need to store substantial or large amounts of information, we can use text for this, okay? So this is large text fields. You might want to store a paragraph of text or a largish, block of text or something that's associated with it. So it could be, thousands of characters. So the text is a large text field, and it can go from 1 to 65535 characters. So it's quite large, okay? TinyInt, very useful as well. So this is for very small numeric values. So it can be -128 to 127 or 0 to 255. So this could be good for storing someone's age, a good example of it, okay? So int is our standard integer, and the range for that is actually quite large, okay? So ideally we need to choose the appropriate data types for the information we're storing. So we should be examining the information type that we're actually going to store, the potential range of the values that may be coming into this, and then we choose the appropriate data type based on it. And the next set we're going to look at is some of the date times, okay? So we could have a standard date, which will be in kind of year, month, day format. We have date time, which is the year, month, day, and then we go after hours, minutes, and seconds. We have our timestamp. Now the timestamp looks a little strange, but it's basically just going to hold a number of seconds between the date that we've actually created a timestamp and the 1st of January 1970, okay? So if someone was to count all of the seconds between, let's say, today and whatever back to the 1st of January 1970, we could be getting something similar to what we have here, okay? We could store something as time, hours, minutes, and seconds, nothing complicated about that. And then we have our year. So this could be 2-digit, or 4-digit. So potentially 4 digits better, or we'll end up with the Y2K problem again, okay? So usually we'll go after something that'd be a 4-digit year that we're going to store, okay? So they're the basics that we have. We'll explore these further as we're going, and we may look at some of the more, some of the different types that are there that we haven't listed at the moment. The list is quite comprehensive. So we've only listed like some of the common ones that is going to meet our needs for the next couple of weeks, okay? So the best way to learn this is to do it by example. So let's say that this is the theory of what our structured query language is, and we've said what create table is, and so on and so forth. Fantastic. Let's see an example of this working, okay? So I'm going to use the MySQL Workbench to access my underlying MySQL database, and I'm going to create a new schema, i.e. create a new database, and I'll create a new table, which is called member. So similar to my little entity relationship diagram here, I'm going to have a member ID, a first name, a last name, a date of birth, and an email, okay? So member is my entity, and my attributes are member ID, first name, last name, date of birth, and email. Member ID is underlined. So this is telling us that the member ID is going to be the key. Okay, well, that makes sense. We need to be able to uniquely identify something in the table. Maybe I want to be able to update it, change it, perform operations on it. So it should be possible to uniquely identify a particular row that's stored in our database table. So fantastic. So this is the syntax we're going to follow, and I'm going to type this in now in a minute, okay? So first we need to define the create table syntax and define the table name. The roundy brackets, or our round brackets, are used to contain the column names, and the data type declarations that are associated with them. So these are our attributes, okay? So each SQL statement terminates with a semicolon. This is, if we're just performing one straight query, it's not usually an issue, but if we were to create a larger script that's going to execute a number of queries against the database at the same time, which would be a script, we need to have them separated, okay? So that the database itself knows that one query is ended and another one's actually starting, okay? Okay, so brilliant, let's get started. So MySQL Workbench. So obviously I have these installed already. I'm going to connect to my local database. So local is on 127.0.0.1 and we're operating off port 3306. I'm going to log in as root, so I'm going to click on it. It's going to ask me for my password. Enter, and I'm in. Okay, brilliant. So it's similar enough in kind of looks to the little PHP MyAdmin interface that we've looked at as well, okay? There'll be a lot more features and functionality that come with here. So a lot of what we see over here on the left-hand side gives us some really powerful tools to be able to manipulate the database, to be able to perform backups, imports, whatever we want to do with it, okay? We'll see these in the coming weeks. Here we have, you see it here just listed as schemas on the left-hand side. These are the databases that I currently have on this particular device, or let's say on my particular database server, okay? So I have one here which is my own one, and that's just basically system. So for our example, I'm going to create a new database. Fine. Now a database can be made up of a large number of tables. So sometimes people do kind of get a little bit confused with this, and that when someone says we need a new database table, that they go create a new database. We can include a large number of tables inside the same database. So if we were to draw out our entity relationship diagrams and we have a large number of entities on the diagram, they will all probably live within the same database. So let's create the database. Right click, create schema. Okay, so it needs a new schema name. I'm going to call my database DIT. Nice and simple, apply. So even the workbench and me using this as a graphical user interface is actually writing the SQL code for us. So it's the SQL code to create a database is create schema and the schema name. So DIT, so create database. Okay, and apply. Saying everything's good. Perfect. So you can see over here now on the left hand side, now I have DIT. So I'm going to double click on it to make sure that that's the database that's highlighted, okay? Now I can start operating. So inside my query window, so I can create new query windows if I want them. So query 1 is here for me, okay? So I'm going to create my database. I'm going to create the SQL code to be able to create the database table, okay? So this is how I do it. Create table. Now, we're going to follow the little example that we have, okay? Where's it gone? So we're going to create the database table for member that's here, and we're going to follow the little entity relationship diagram that we have, okay? So create table, members. So we'll try and keep everything as plural, okay? We put our roundy brackets in, open roundy bracket, come down 2 lines, close the roundy bracket and put the semicolon in. So sometimes we can forget to put the roundy brackets in or to close something off. So usually I close it off before I begin. So this is the syntax I have for create table. Now I just need to populate the attributes or the columns in line 2 going onwards, okay? Perfect, so back we go. So let's deal with member ID first. So we want to have member ID to be our unique key or our primary key in our database table, and we want it to be a numeric value or an integer value that's going to auto increment every time something's added to the database, okay? So I'm going to come in 3 lines, 1, 2, or 3 spaces, member underscore ID. We want it to be of type int, not null, and we're going to set it to auto increment. AUTO underscore INCREMENT. And then we put our comma in. And then we go down to the next column, or the next attribute we want to deal with. So the next one is first name. I'm going to set this to be a varchar. See the way I'm using the uppercase, so just so I'll know which kind of, it's a good separator for some of the kind of keywords versus some of our variable names, okay? So first name, varchar 50. Last name, varchar 50. So 50, now I can change these to whatever I want. So I think that to be storing someone's first name and to be storing someone's last name, 50 characters is enough. Now, if that's not enough, then we increase the values. Okay, someone's date of birth, I'll keep it as DOB, and I'm going to store this as a date. Okay, well, I'm going to question that. Why? So I'm going to go back to my little slides. Okay, so these are my data types for dates. So I have date, date time, timestamp, time, and year. And I'm going to pick out the most appropriate data type that's going to be good for storing someone's date of birth. So potentially, I could store it as a date or a date time. Now, I don't think everyone is going to be wanting to type in the exact hour, minute, and seconds for their date of birth, if even someone knows. So it's just a date is what we're interested in. So it's year, month, and day. So the first one's perfect. So date, what we've actually used, is absolutely perfect, okay? I'm going to store someone's email. L. What will I set this to? Varchar. And I'm going to say 100. Now I'm going to gamble that potentially 100 mightn't be enough, but it's good enough for our example, okay? Probably might be better to max out on something like this, because if someone exceeds the 100 characters, the database is going to say, look, I'm not dealing with that, okay? So absolutely fine. Email, and then the last thing we need to do is that our member ID, which is auto increment, for this to work correctly, it has to be set as the primary key. So the primary key is what is going to be our unique identifier for a given row, and equally, if we're going to set up relationships between the members table and other tables, we're going to use the primary key, which is member ID, okay? So all we have to do is define primary. We're saying that this is the primary key for this table. So what is the primary key? Well, it's member underscore ID. So now we have our SQL syntax, okay? So it might be good to save it. So if we want to save what we're after, we can go File, Save Script, and save whatever we want, okay? I'm not going to save it, but if you're building up your own scripts, save them, because you might want to use them or run them again at a later date, okay? And I will show that once we've executed this, that at a later date, if we want to, back up our schema or convert it into a text file so we can actually have this again, we can. And we'll see this a little further on down the line, okay? So now we have create table members, roundy bracket, member ID, int, not null, auto increment, first name varchar 50, last name varchar 50, date of birth date, email varchar 100, and we've set the primary key to be member ID. And where's this coming from? Well, it's relating to our member ID, which is up here. And equally, each row that we have, or each column or attribute that we've added in, there's a comma between them, and the comma goes the whole way down except for the last one that's defined here, okay? So if I was to put a comma in here, it's a problem. So you can see we don't want one here, okay? You can see it's even given out as is. I put it in, there's a problem. So that's what we have. So to run our query, we click the little lightning bolt, okay? And we're coming down here and it's saying create table, 0 rows affected, and this is how long it's taken. Okay, absolutely fine. So if I come back over to my database table that I have here, so I'm just going to refresh it, and you can see here that tables has now given us a drop down and members is here for us. Brilliant. Drop down again. It's telling me columns, indexes, foreign keys, and triggers. Well, they're all my columns. Here are my indexes. So fine, foreign keys, none associated with it, and no triggers. So perfect. So I have member ID, first name, last name, date of birth, and email. Okay, so that's the format that we follow for using our SQL code to create our database table. Okay, so if I didn't want this to be members, I could change this to students, and I could juggle around my columns or attributes any way I see fit. Okay, so we can follow the exact same process that we have here to create any type of database table. Okay, so that's our create table. In the next video, we're going to look at inserting some information into our database tables. Okay, so I hope you found this helpful, and if you have any questions, please let me know. Thanks.